Beneath the eternal rhythm of dawn and dusk, Earth has always been a planet of light. Every leaf, every heartbeat, every rise of civilization rests on the faithful return of the sun. But deep within the planet's memory lies an older story, a time when that rhythm was broken, when light faltered and the world was plunged into a darkness that lingered not for days or months, but for years. The sky, once painted in the colors of morning, turned into a veil of ash and shadow. Stars still pierced the heavens, cold and distant, but they offered no warmth. The horizon did not glow, and the earth lay cloaked in a silence heavier than death. Crops withered, oceans cooled, forests dimmed into graveyards of colorless leaves. Humanity had not yet risen, but life trembled, and whole kingdoms of creatures would vanish into the night. For those who lived through fragments of this terror, in more recent ages, the sudden winters after great volcanoes, the year without a summer when the sun seemed to fail, the memory was almost mythic, whispered as omens of divine punishment, but in stone and ice, in soot and shattered fossils. Science would later find a darker truth, that once the earth endured not a season, but nearly a decade where daylight itself was stripped away. What force could smother the sun? A mountain's fury, a falling star, or something far more distant and cosmic? The planet survived, scarred and changed, carrying forward the faint whispers of that catastrophe. Yet one question lingers, haunting and unresolved. How did life endure the silence of a sunless sky, and what secrets remain hidden in the shadows of that ancient night? In the oldest myths, preserved in the voices of ancestors long gone, echoes of a vanished sun resound like faint warnings. The Norse sagas spoke of the Fimbulwinter, an endless cold that blanketed the earth before the end of days. In Mesoamerican lore, the sky itself was said to fall silent, the sun refusing to rise, as if the gods had turned their faces from the world. To ancient peoples, these were stories of punishment and rebirth, divine allegories of death and renewal. Yet, hidden beneath the poetry of myth, modern science would later hear something deeper, a whisper of memory, carried across generations, of skies that truly darkened and refused to let light return. The earth itself holds more faithful records than human memory. Deep in Greenland's ice, in layers stacked like pages of a planetary diary, strange anomalies appear, sudden drops in trapped greenhouse gases, chemical fingerprints of sulfur and ash, horizons where the air seemed to thicken with soot. In lake sediments and ocean floors, blackened bands of carbon betray the scars of ancient firestorms, suggesting forests burned on a global scale, sending their smoke to veil the sun. In the 19th century, the world was given a fleeting glimpse of what such an age of darkness might have been. In 1816, after the violent eruption of Mount Tambora in Indonesia, the northern hemisphere was shrouded in ash. Crops failed under frozen midsummer skies, famine rippled across continents, and the year became known as the year without a summer. To poets and scientists alike, it was a moment of awe and terror, a small reminder that the Earth's warmth hangs by a fragile thread of light. As paleontologists traced the fossil record, they found intervals of sudden ecological collapse, forests dying, oceans silenced, whole chains of life unraveling. These were not gradual extinctions, but sharp, brutal breaks, as if the earth itself had turned off its lamp. Slowly, a possibility emerged, that more than once in its history, Earth had endured not simply nights, not merely winters, but decades of darkness born from catastrophe. Volcanic winters, cosmic impacts, perhaps even forces more remote, All became suspects in a mystery too large to dismiss. What once seemed a metaphor in legend, what once seemed impossible to early science, began to reveal itself as history. That there was a time when the sun itself was hidden, and the earth trembled under its absence. These fragments of evidence, scattered across continents and disciplines, began to converge into a single, unsettling vision. Myths of endless night, strange signatures in ice, and abrupt ecological breaks in stone all hinted at the same truth. Earth has known darkness that endured. For centuries, such a concept seemed absurd, the realm of mythmakers and poets, not scientists. Yet, as the tools of geology sharpened, as microscopes traced ancient pollen, and as chemical analyses revealed traces of soot and sulfur, it became harder to deny that the world had, on more than one occasion, faced skies stripped of light. The revelation was as humbling as it was terrifying. The sun, the most constant presence in human existence, had not always been visible. There were times when it was there, burning as always, but unreachable, its light smothered by the breath of the earth or by debris from beyond. The idea of darkness as physical history, not spiritual allegory, reshaped the way science began to view catastrophe. The earth, once thought to change only slowly and steadily, was now revealed as fragile, subject to sudden plunges into chaos. The comparison between the Tambora eruption and older, grander events was irresistible. If a single volcano could freeze harvests on the other side of the globe for a season, what would happen if something 10 times or 100 times greater were to fill the sky? The answer seemed to lie waiting in geological memory, fossilized. Plants that died in mid-growth, interrupted by abrupt famine of light. Plankton in ocean cores that vanished suddenly, as though the sea itself had been cut off from the sun. Animals that starved in landscapes where vegetation never returned. In time, each discovery added another layer to the riddle, another clue that the Earth's past held events so extreme that myth alone could not contain them. Slowly, the seed of a new mystery took root in scientific thought, that somewhere in the deep past, perhaps more than once, there had been not simply a year of dimmed skies, but a span of darkness lasting close to a decade. Not a winter caused by tilt or orbit, but a global veil drawn across the heavens, reshaping every living thing that depended on light. This was not my imagination. It was not a metaphor. It was history written in ice, in ash, in silence. And it was only the beginning of the search for how such darkness could come to be, when the first whispers of prolonged darkness surfaced in the scientific world. They clashed with a doctrine that had long shaped geology and natural history. Charles Lyell's vision of uniformitarianism had argued that the Earth changed slowly, through steady forces stretched across vast ages. Rivers carved valleys, mountains rose by imperceptible degrees, and climate shifted only through gradual turns. To imagine otherwise, to speak of sudden cataclysmic upheavals, was to invite ridicule. Darkness that swallowed the world for years seemed more the stuff of prophecy than of science. Yet as evidence accumulated, the simplicity of a slow and stable Earth began to erode. The year 1816 had left a scar on human memory, a smaller echo of what such a world might feel like. In the aftermath of Tambora's eruption, skies dimmed to the color of lead, crops failed, and famine spread across continents. For the first time, the idea of atmospheric collapse was felt not as a theory, but as lived experience. Farmers in New England watched frost kill their fields in midsummer. Villages in Europe starved as harvests withered under grey skies. Poets wrote of a sun that had been extinguished, while scientists, stunned, began to calculate just how fragile the atmosphere was to veils of dust and ash. In that climate of confusion, comets and meteors entered the discussion as possible culprits. For centuries, they had been harbingers of doom in the night sky. Now, some thinkers wondered whether they could bring not only fire but darkness, throwing up veils of debris that might shroud the earth. Others argued for purely terrestrial causes. Vast volcanic eruptions beyond human memory, storms of fire that could dim the heavens. But to many climatologists, the idea of decades-long nights bordered on impossible. Plants required sunlight within weeks, animals within months. Entire food webs would collapse in less than a year. How could any ecosystem endure such a silence of light without vanishing entirely? Still, the fossils spoke of survival. The ice spoke of recovery. Life had endured, somehow, through events that seemed mathematically unlivable. Slowly, a shift began to take hold in scientific thought. Perhaps the Earth was not destroyed in these intervals because it was not light itself that vanished, but light diminished, starved into weakness. The connection between atmosphere and sunlight was no longer poetic but material. A single veil of dust or ash could mean the difference between warmth and ice, between flourishing forests and silent wastelands. The mystery deepened, and with it grew an unease that the very breath of the earth, its storms and eruptions, or the silent approach of a rock from space, could extinguish the sun from human sight and leave the planet to wander through years of twilight. As the debates grew, science itself stood at a crossroads between two worldviews. On one side lay the comfort of Lyell's steady Earth, an ancient planet guided by time's slow hand. On the other rose the spectre of catastrophe, sudden and violent, rewriting landscapes in the span of a generation. Darkness became the battlefield of these ideas. If prolonged night was real, it meant that the Earth's balance could be overturned in moments, its stability only an illusion. This realization unsettled more than geology. It reached into philosophy, into humanity's sense of permanence, revealing that even the sun, the most constant image in human existence, could be stolen, not by vanishing, but by being smothered. The Tambora eruption had proven the concept on a human scale, yet it also underscored how fragile civilization truly was. In an age without industrialized farming or global food transport, famine swept nations in less than a year. Starvation, disease, and social unrest revealed that even a single volcanic veil could ripple across societies with devastating force. Two scientists of the 19th century, the leap from one summer of darkness to a decade seemed almost unthinkable. The numbers did not add up. Photosynthesis would halt, oxygen cycles would falter, oceans would turn lifeless. Yet geological records showed collapses that were larger, sharper, and far older than anything Tambora alone could explain. The contradiction was undeniable. Early climatologists began sketching primitive models of atmospheric opacity, calculating how dust, ash, and aerosols could scatter sunlight across the spectrum. Even with partial light, ecosystems might cling to survival, albeit through mass, suffering, and collapse. The margin was razor-thin, a knife edge between endurance and extinction. From these studies emerged the first fragile acceptance that decades of dim skies, while devastating, were not beyond the laws of nature. The veil might thin and thicken, letting faint light sustain a world at the brink, until the skies cleared and life began its long crawl back toward balance. In this uneasy reconciliation, the seed of a new understanding was planted. The earth was not governed by uniform serenity, nor by endless chaos, but by a fragile interplay of both. It could remain stable for ages, then lurch violently into upheaval, only to return again to quiet rhythms. Darkness was not merely myth. It was a force that had pressed itself into the bones of the planet, waiting for science to uncover its trace. The first reactions were marked by disbelief, resistance, and fear. Yet they also marked the beginning of a profound shift, a recognition that the survival of life was not guaranteed by the constancy of the sun, but by the resilience of the earth beneath its temporary absence. The first true investigations into the mystery of darkness did not begin with myth or speculation, but with the silent evidence locked deep within the earth itself. In cores drilled from ancient rock and ice, scientists uncovered thin, unmistakable layers blackened with soot and laced with sulfur. These were fingerprints of cataclysm, remnants of skies once filled with smoke and ash. Each band told of firestorms that raged across continents, forests reduced to embers, and oceans suffocated beneath veils of particles drifting in the stratosphere. In these layers, the planet's own memory began to reveal that the darkness was not allegory but fact. Preserved in the chemistry of stone, volcanic eruptions offered the first accessible window into such events. Krakatoa in 1883 sent shockwaves around the globe. Its eruption heard across oceans, its plume scattering sunsets into blood-red and violet hues. The earth cooled measurably in the years that followed. Harvests failed, and the fragility of climate became undeniable. Yet even Krakatoa, one of the most violent eruptions in recorded history, was but a pale shadow of the events that scientists began to suspect had once shaken the planet. Tambora in 1815 had already given the world a year without a summer. Krakatoa's legacy confirmed that eruptions could wound the climate itself. But what if there had been eruptions, many times larger, far beyond the scale of human memory? Supervolcanoes, capable of releasing thousands of times more ash, could conceivably smother the sun for years. It was a terrifying possibility, but one increasingly difficult to ignore as geology wrestled with Earth's violent potential. Astronomy began to entertain darker questions. What if the sun itself faltered? Could it dim or vanish, even briefly? In the 19th century, this was speculation born of limited understanding. Yet it reflected the growing anxiety that the universe might not always provide stability. Later, science would confirm that the sun's energy is steady on human timescales, its nuclear furnace unbroken across millions of years. But while the star itself remained faithful, its light could still be stolen, not at the source, but in the fragile space between star and planet. Dust, ash, and debris could silence sunlight without touching the sun at all. The rise of paleoclimatology gave this mystery new precision. Fossilized plants revealed abrupt interruptions in growth, their rings thin and distorted, their tissues scarred by sudden deprivation. In coal deposits and petrified forests, entire ecosystems seemed to vanish in moments, replaced by signs of cold and famine. The earth had not simply cooled slowly. It had been struck, shocked, and buried in intervals of abrupt night. Ice cores provided further proof, each bubble of trapped air a time capsule of atmosphere. In them lay evidence of sudden drops in temperature, shifts in carbon dioxide, and surges of sulfuric compounds. Chemical whispers of skies once veiled. Human imagination could not remain untouched by these discoveries. Writers of the 19th and early 20th centuries found inspiration in the science of catastrophe, painting worlds swallowed by shadow. Novels and poems described suns that failed, lands consumed by winter, and civilizations brought to ruin under endless grey. What had once been mythic prophecy now found new resonance, grounded not in divine wrath but in scientific evidence. These stories were not merely entertainment. They were attempts to grapple with the terrifying fragility revealed by geology and climate that through these early investigations, a picture began to form. The Earth was not a stage of eternal stability, but a world vulnerable to sudden silencing of light. In soot, in ash, in fossils and ice, the planet whispered the same story again and again, that there were times when the sun rose, but its light never reached the ground. The realization unsettled every field of inquiry. Darkness was no longer a metaphor nor a relic of myth. It was history written in the layers beneath our feet, waiting for those brave enough to read it. The deeper scientists looked, the more the evidence seemed to weave into a single haunting narrative. Each core sample, each fossilized leaf, each thin horizon of ash in the rock record spoke of events so immense they defied imagination. Volcanic winters and impact winters emerged as recurring motifs in the planet's story, not isolated tragedies, but rhythms of destruction woven into the fabric of geological time. What had once been dismissed as coincidence, a strange band of soot here, a sudden disappearance of plant life there, began to align across continents, forming a planetary-scale puzzle. The revelation was sobering. These were not local disturbances but global veils, moments when Earth itself was plunged into twilight. To those piecing the story together in the late 19th and early 20th centuries, the implications were staggering. Civilization had only just begun to map the depths of Earth's past, to understand that species had risen and vanished in epochs long before humanity appeared. The idea that entire biospheres could collapse in the span of a few years, driven not by slow decline but by the loss of light itself, reshaped how scientists thought about extinction. It was not only predation, competition, or gradual climate shifts that sculpted life, but also sudden, unpredictable calamities that tore the chain of being apart in an instant. The soot in ancient sediments was more than chemical residue. It was a signature of fire and famine, of skies gone dark, of survival hanging by a thread. The more the mystery grew, the more the human imagination tried to make sense of it. Literature became a mirror of the unease that science uncovered. Mary Shelley, writing in the shadow of Tambora, envisioned a world bereft of harvests, of warmth, of hope. Later, H.G. Wells would draw on similar fears, casting his speculative futures under suns that dimmed or vanished. These were not idle fantasies, but reflections of a deeper cultural anxiety that humanity itself might someday face the silence of a lightless sky. The blending of fact and imagination revealed something profound. Science was not only rewriting history, it was unsettling the future, hinting at vulnerabilities that no empire, no civilization could escape. By the time the 20th century dawned, the foundation of a grand mystery had been laid. The Earth's archives, in stone, in ice, in myth, and in the imagination of its people, all pointed to the same inescapable truth. There had been times when light itself was stripped away, when the planet survived only by enduring the long passage through a night that seemed eternal. These early investigations did not solve the riddle. They sharpened it, deepened it, and ensured that generations of scientists to come would be compelled to ask the same haunting question: What force could take the most constant element of life, the sun, and hide it from the world below? The mystery of Earth's ancient darkness stood unresolved until the late 20th century, when a father and son turned their attention to a thin layer of clay that marked one of the most profound breaks in the fossil record. Luis and Walter Alvarez, working in the hills of Italy, measured concentrations of iridium, a metal rare on Earth but common in asteroids. At the boundary between the Cretaceous and the Paleogene, 66 million years ago, this thin band of sediment marked the sudden disappearance of the dinosaurs and countless other forms of life. To the Alvarezes, the evidence pointed to a single, catastrophic cause: the impact of a massive asteroid. Their proposal was audacious, challenging decades of thought that extinctions unfolded slowly, but it opened a new doorway into the possibility of global nightfall. The search for confirmation led to the Gulf of Mexico, where geologists identified the Chicxulub crater, a scar more than 180 kilometers wide, buried beneath the Yucatan Peninsula. Here, a space rock over 10 kilometers across had struck the planet with unimaginable force, releasing energy greater than billions of nuclear weapons combined. The impact ignited forests across continents, sent shockwaves around the globe, and hurled trillions of tons of rock and sulfur into the atmosphere. In that moment, the Earth itself became a furnace, burning skies collapsing into a world destined for shadow. Across continents, scientists traced layers of soot in the rocks of this time, a black horizon found in North America, Europe, Asia, and beyond. It was not the residue of local fires, but of a planet-wide inferno. Forests and grasslands turned to ash. Above that soot, sunlight failed. Dust and aerosols, lofted into the stratosphere, would have scattered and absorbed the rays of the sun, dimming day into twilight for months, even years. Advanced climate models now simulate the aftermath: oceans cooling by several degrees, photosynthesis collapsing, food webs disintegrating from plankton to predators. The catastrophe was not merely an instant of fire, but a decade of darkness, each year pressing ecosystems closer to collapse. Fossil records tell the story of this lingering night. Plants vanish suddenly, leaving only spores of ferns, pioneer species able to grow in devastated, light-poor landscapes. Marine plankton, the foundation of ocean life, suffered sharp declines, their absence echoing up through fish, reptiles, and mammals. Entire families of creatures disappeared, not because of the impact's initial firestorm, but because the skies failed to brighten again. Survival meant adapting to scarcity, enduring years where energy from the sun was rationed through a thick veil of ash. This was the breakthrough, a unifying vision, where global darkness was no longer myth or speculation, but geological certainty. The Earth had been plunged into shadow not once, but perhaps many times across its history. The Chicxulub impact revealed what had been long suspected, that the world could survive years without light, though at an enormous cost: the extinction of the dinosaurs was not merely the story of fire from the sky. It was the story of a planet suffocated in shadow, reshaped by the absence of its most essential ally. The realization was unsettling in its scale. Darkness was not an anomaly confined to ancient myth or isolated eruptions. It was a recurring force, a silent player in Earth's history, capable of resetting the course of evolution in a single decade. The dinosaurs had ruled for over 160 million years, but a shroud of twilight lasting less than a generation brought their reign to an end. And in the silence that followed, new life, fragile mammals and flowering plants began to rise, heirs of a world forever marked by the memory of night. From that moment, science understood the true stakes of its investigation. The Earth did not merely orbit the Sun. It depended on a fragile stream of light that could be severed at any time by fire from within or by a single rock from the void. The breakthrough was not only a discovery of the past, but a warning etched into the future. Global darkness is part of the planet's story, and it may one day return. As the evidence mounted, researchers began to see patterns extending far beyond the Chicxulub event. Soot layers of similar composition appeared in older strata, hinting that asteroid impacts and supervolcanic eruptions had conspired repeatedly to cast the Earth into shadow. Each layer was a frozen diary of fire and night, a testament to the fragility of life when sunlight was withheld. In the oceans, the collapse of plankton populations rippled through ecosystems, echoing in fossilized fish and marine reptiles. On land, plant communities were uprooted, forests reduced to skeletal frameworks preserved in stone. The message was clear: darkness was not a singular catastrophe, but a recurring theme in the planet's history, a force capable of reshaping life itself. Simulations of these ancient cataclysms brought the reality into sharper focus. Using modern climate models, scientists recreated the clouds of dust and sulfur projected by a massive impact. Sunlight, once steady and life-giving, was scattered and absorbed, leaving a dim, cold, and hostile world. Temperatures plummeted, photosynthesis slowed to a crawl, and the energy that fuels ecosystems vanished almost entirely. Even resilient species were pushed to the brink. Survival required adaptation on a timescale that challenged biological limits. These virtual reconstructions turned speculation into tangible scenarios, revealing a planet enduring the stress of near-total darkness, yet somehow persisting. Fossil evidence corroborated the models in haunting detail. Tree rings showed years of stunted growth, pollen grains were sparse or absent, and marine microfossils disappeared from sediment layers for extended periods. Life had not merely survived the immediate catastrophe, it had endured the lingering shadow that followed. Mammals and birds, plants and insects, all faced a world where light was rationed and energy scarce. The extinction events were not instantaneous. They were prolonged trials, testing the resilience of every ecosystem. In this context, darkness emerged as both destroyer and sculptor, erasing some forms of life while giving rise to others capable of enduring the silence of the sun. This recognition reshaped the scientific understanding of Earth's vulnerabilities. Global darkness was no longer theoretical. It was a measurable, recurring phenomenon. The planet's history was punctuated by moments when firestorms and debris could dim the sun for years, halting the rhythms of life and challenging the very concept of survival. The Alvarez hypothesis and the discovery of Chicxulub were not mere milestones in paleontology. They were gateways into a deeper understanding of the planet as a delicate balance of light and shadow. They revealed that life's persistence was a story written not only in warmth and growth, but in resilience under the weight of an extended, oppressive night. In the aftermath of these breakthroughs, the philosophical implications became impossible to ignore. Darkness was not an anomaly confined to legend or imagination. It was a force that had repeatedly shaped the trajectory of life on Earth. The very survival of ecosystems, the rise of new species, and the extinction of others were all contingent upon the return of light after a period of suffocating shadow. Humanity, arriving millions of years later, inherited a world scarred by these events, yet alive because life had adapted to endure them. The breakthrough was both scientific and existential. The Earth had survived years without sunlight, but, in doing so, it carried the silent reminder that light is fragile, and darkness, though rare, is a force to be reckoned with. The deeper scientists probed the shadows of Earth's past. The more complex and unsettling the picture became. Darkness was not a singular event, nor a simple consequence of fire and ash. It took many forms, each with its own signature of destruction. Volcanic winters, the product of gargantuan eruptions, could hurl sulfur and soot high into the stratosphere, shading the planet for years and cooling the climate in ways that left ecosystems on the brink. Impact winters, by contrast, carried the additional violence of kinetic energy, igniting forests, vaporizing oceans, and spreading debris in a planetary storm that could blot out sunlight entirely. Though the mechanisms differed, the outcome was eerily similar: a prolonged suppression of the sun's life-giving rays, an enforced twilight stretching across continents, and a test of survival written in the chemistry of stone and ice. The eruption of Toba, nearly 74,000 years ago, offers a stark example. One of the largest supervolcanic events known, it released volumes of ash and aerosols sufficient to dim the sun for years. Climate models suggest that global temperatures fell dramatically, triggering near-extinction conditions for early humans and forcing entire ecosystems to adapt or perish. Genetic studies hint at a population bottleneck during this period, a reminder that even the most resilient species are vulnerable to the sudden absence of light. The Earth had survived, yet it bore the deep scars of such events, inscribed in genomes, in fossilized flora, and in the very soils that sustained life after the dark. Beyond terrestrial causes, the cosmos itself offers further shadowed possibilities. Gamma-ray bursts from distant supernova, rare but unimaginably powerful, could strip away the atmosphere's protective layers, triggering chemical reactions that block or scatter sunlight. A nearby supernova could bathe the planet in lethal radiation while simultaneously casting it into an extended period of dim skies. Though improbable, such events remind us that the fragility of life is not confined to the surface of Earth. It is woven into the fabric of the universe itself. Even human technology now demonstrates the potential for creating darkness on a planetary scale. Nuclear winter models, developed during the Cold War, reveal that the detonation of modern arsenals could release enough soot into the stratosphere to lower global temperatures, dim the sun for years, and threaten the delicate balance of ecosystems worldwide. The search for understanding has demanded an unprecedented convergence of disciplines. Geologists trace layers of ash and soot. Climatologists model the cascading effects on temperature and precipitation. Astronomers map celestial threats capable of dimming the skies. Each field independently illuminates part of the story, yet together they reveal a chilling coherence. Darkness is not a relic of the past, it is a recurring possibility. It is a force that has shaped evolution, challenged survival, and tested the resilience of life across millions of years. And as the data accumulate, an unnerving question takes shape. No longer confined to history, it is not a matter of whether the world could be plunged into darkness again, but when. The Earth has endured long nights before, but those nights were neither kind nor forgiving. They remind us that light, so constant and so taken for granted, is a fragile gift, one that can be stolen in moments by forces both natural and, potentially, human-made. The shadow of that knowledge stretches across millennia, a silent warning echoing in the fossil record, in ice cores, and in the simulations of the future. As the mystery deepened, the line between imagination and evidence began to blur, revealing a planetary narrative both mesmerizing and terrifying. Supervolcanoes like Toba were not mere geological curiosities. They were agents of near-apocalyptic change. Layers of ash, preserved in lakes and sediments across Asia, spoke of skies choked with particulate matter where sunlight struggled to penetrate a veil of fire and dust. Models suggest that photosynthesis slowed to a crawl, crops and wild vegetation alike withering under a muted sun. Early humans, small in number and already vulnerable, faced an evolutionary crucible. Genetic studies imply that this episode may have narrowed our species' population to a few thousand, a reminder that even resilient life can teeter on the edge when darkness persists. The potential for cosmic catastrophe adds a further, unsettling dimension. Gamma-ray bursts, released in distant galaxies, can bathe a planet in high-energy radiation while stripping away protective atmospheric layers. Nearby supernova can scatter dust and radiation capable of dimming the sun for years. Though these events are rare, their consequences echo the same theme. The Earth is not isolated from the universe, and its ecosystems are subject to forces that operate on scales both immense and indifferent. Each hypothesis, volcanic impact, cosmic threads together a tapestry of vulnerability, revealing that the Earth's history of darkness is not a one-off occurrence, but a pattern, a recurring trial in which life's endurance is tested. Repeatedly, the Cold War introduced an unnerving contemporary reflection of this ancient vulnerability. Models of nuclear winter, once theoretical exercises in military planning, demonstrated that human activity could replicate the conditions of ancient darkness. Soot and debris lofted into the stratosphere from widespread firestorms could scatter sunlight, lower global temperatures, and collapse ecosystems, echoing events from deep time. Humanity, armed with knowledge and technology, has become capable of imposing darkness upon itself, a profound reminder that the forces which shaped the planet in the distant past are mirrored, in miniature, in human hands today. Interdisciplinary research reinforces the starkness of the picture. Geology provides the scars in stone and ice. Climatology reconstructs the shifting temperature and precipitation. Astronomy maps threats from beyond the solar system. Together, they reveal an unsettling continuity. The Earth has endured prolonged darkness many times, and each instance left a mark, reshaping life, climate, and the very biosphere. The question is no longer whether darkness can occur again. It is when and how life will endure its silent, suffocating passage. The deep past, etched in soot, ash, and ice, whispers a warning that resonates in the present. The sun, though eternal in human perception, can be temporarily stolen, and survival depends on the fragile resilience of a world living in the shadow of its own light. Beyond the familiar terrors of volcanoes and asteroid impacts, science begins to peer into the vast, indifferent cosmos for threats so remote they border on speculation, yet remain rooted in physics. The universe is not static. It is a turbulent, shifting expanse, and Earth moves within it like a small vessel in a sea of possibilities. Interstellar dust clouds, drifting silently across. The solar system could conceivably obscure the sun's light for years or even decades. Though the likelihood is small, the physics is simple. Particles dense enough to scatter sunlight could lower global temperatures, disrupt photosynthesis, and dim the daily rhythms of life. The planet's history teaches that even improbable events must be considered, for they may carry consequences no less devastating than a supervolcano or asteroid, on timescales that stretch across millions of years. Even the Sun itself is not immutable. Stellar evolution predicts slow changes in luminosity, but models also entertain rare instabilities, flares, coronal mass ejections, or shifts in nuclear fusion rates that could temporarily alter the energy reaching Earth. Our star, so familiar and so constant, may have minor tremors in its vast life cycle that, in combination with other cosmic factors, could cast the planet into prolonged dimness. When combined with other mechanisms, interstellar clouds, orbital shifts, or galactic density variations, these small fluctuations acquire a cumulative power, a reminder that Earth's safety is never guaranteed by proximity to the Sun. Alone, speculative physics offers yet stranger scenarios. Black hole accretion events, the collisions of massive stars, or the disruption of distant planetary systems could hurl debris or radiation toward the inner solar system. A shroud of cosmic dust, ignited or scattered by gravitational upheaval, might momentarily blot out the Sun, echoing the catastrophic nights of Earth's deep past. These are extreme-edge possibilities, residing on the boundary between current knowledge and imagination. Yet they remind us that our planet exists in a web of forces both seen and unseen. A fragile island of life in a turbulent cosmic ocean. From this deep-time perspective, Earth's vulnerability becomes undeniable. The threats are no longer confined to fiery mountains or falling rocks. They extend across light years, across time itself, to phenomena so immense and impersonal that human observation may only ever glimpse their shadow. The fragile truth emerges with startling clarity. Light, our most constant ally, is not eternal. Every ray that warms the earth and nourishes life is contingent, fleeting in the cosmic scheme. The history of darkness teaches that survival has always depended on resilience and adaptation, and that the Sun's presence, though unwavering in daily perception, is a gift vulnerable to forces both near and unimaginably distant. The extreme edge of science thus reframes the mystery. Earth is not merely a stage for geological events, but a participant in a universe whose laws can impose darkness at scales beyond human comprehension. The threat is subtle, the mechanisms complex, and the consequences profound. It is a reminder that light itself, which seems so permanent, is ever at the mercy of the cosmos, a lesson written in stone, ice, and the faint whispers of stars. Across the dark void, viewed across the span of geological time, these astrophysical possibilities transform the Earth, from a secure cradle of life into a delicate vessel navigating an unpredictable cosmos. Interstellar clouds, while diffuse, are vast and relentless, drifting through the galaxy over millions of years. Should the solar system pass through one of these denser regions, sunlight could be scattered or absorbed in ways that subtly, then dramatically, alter climate. Seasons might shorten, winters lengthen, and ecosystems, finely tuned to the rhythms of light, would strain against deprivation. It is a slow, almost imperceptible threat, yet cumulative, capable of producing effects that rival, or even exceed, the familiar horrors of volcanoes or asteroid strikes. The Sun itself, so intimately entwined with life on Earth, may harbor instabilities imperceptible on human timescales, but significant across millions of years. Stellar physics allows for episodic flares, shifts in solar output, or variations in magnetic activity that could reduce the effective energy reaching the surface. Even minor reductions, sustained over decades or centuries, could suppress photosynthesis, cool the oceans, and disrupt food webs. When coupled with other cosmic influences, orbital variations, galactic dust, or passing stellar remnants, the sun's apparent constancy becomes an illusion, and life's reliance on it appears precariously balanced. Speculative, but physically grounded scenarios, such as black hole accretion events or the fallout from distant supernova, emphasize Earth's exposure to forces beyond comprehension. Debris, radiation, or energized gas clouds could intersect the solar system, temporarily shrouding the planet in darkness. These events are rare, almost unfathomably so, yet history reminds us that improbable does not mean impossible. The paleontological and geological record bears witness to the extraordinary resilience of life, but also to its vulnerability when light itself is denied. Each episode of prolonged darkness etched scars into the biosphere, leaving behind evidence in soot, ice cores, and fossilized flora and fauna. In this view, Earth is both resilient and fragile, a world whose survival has depended on enduring the absence of light more than once. The extreme edge of science expands the imagination, yet it is not mere speculation. It is a reminder, drawn from physics, astronomy, and deep-time observation, that light is not guaranteed. The sun, which appears eternal from daily experience, is part of a universe that can impose darkness in ways both subtle and cataclysmic. This recognition reframes existence itself. Every living being is sustained by a fragile flux of energy, and every moment of daylight is a temporary reprieve in a cosmos capable of silence, shadow, and extended night. The profound implication lingers like a shadow across the mind. The earth, and life upon it, persists, not because light is eternal, but because resilience has allowed survival through its absence. From interstellar clouds to stellar instabilities, from black hole debris to dense galactic neighborhoods, the potential for prolonged darkness is written into the architecture of the universe itself. It is a humbling, unsettling truth, one that elevates the mystery of the time darkness once covered the Earth into a story not merely of the past, but of our planet's ongoing vulnerability, poised on the edge of cosmic forces we can barely imagine. The leading explanations for Earth's most profound episodes of darkness converge on forces both immense and tangible, the kind that leave scars visible to science even millions of years later. Chief among these is the impact of the Chicxulub asteroid, a cataclysm so immense that it reshaped the very face of the planet. The collision, 66 million years ago, released energy beyond human comprehension, hurling vast clouds of rock and sulfur into the stratosphere. Sunlight filtered through these dense layers, dimmed to the point where photosynthesis slowed to a near halt. Climate models suggest that temperatures fell sharply, plunging the Earth into a prolonged twilight that endured for years. In this shadow, ecosystems teetered on the brink, many collapsing entirely, yet life endured, leaving behind fossilized traces that allow modern science to reconstruct the event with startling clarity. Supervolcanic eruptions offer another equally formidable explanation for prolonged darkness. Toba, nearly 74,000 years ago, and Yellowstone, with its massive caldera eruptions, injected staggering quantities of ash and aerosols into the atmosphere. Ice core studies provide a precise record of these events, revealing layers rich in sulfur and particulate matter, the chemical signatures of skies smothered by fire. Models indicate that sunlight, filtered through these volcanic clouds, could have been dimmed for years, reducing global temperatures and triggering cascading disruptions in ecosystems. Crops failed, forests withered, and the oceans, deprived of sunlight, struggled as photosynthetic plankton populations declined, destabilizing the marine food web from bottom to top. The disruption of the carbon cycle during these periods highlights the broader ecological consequences. With photosynthesis slowed, atmospheric CO levels fluctuated, and oceans absorbed more carbon than usual, leading to acidification that stressed marine life. Plankton, the foundation of oceanic ecosystems, experienced massive die-offs, while terrestrial plants suffered from the reduced light and colder temperatures. Entire food webs collapsed, leaving only the most adaptable species to survive the prolonged darkness. Yet despite this devastation, life has always found a way to recover. Forests regrow, oceans recolonize, and evolution continues, reshaping the biosphere in the aftermath of catastrophe. These mainstream theories reveal a paradox. At the heart of Earth's history, the planet is capable of enduring forces that threaten total collapse, yet the scars of such events remain etched into the geological record. Each episode of darkness tests the resilience of life, but also transforms it, leaving the world forever altered. The Chicxulub impact, supervolcanic eruptions, and the repeated volcanic winters captured in ice cores offer a coherent framework to understand how Earth could have endured a decade of near-total darkness. They are reminders that survival is never guaranteed, yet that the mechanisms of life are extraordinarily tenacious, capable of withstanding even the most profound assaults on the sun's gift of light. The mainstream perspective emphasizes that darkness is not an anomaly or a myth, but a recurring phenomenon with real, measurable causes. Catastrophic impacts, titanic eruptions, and their climatic consequences form the strongest candidates to explain why Earth has periodically been cast into shadow. These forces, though violent and indiscriminate, operate within the bounds of known physics and chemistry, making them both terrifying and comprehensible. In each instance, the planet emerges from darkness changed, ecosystems restructured, species replaced, and the trajectory of evolution subtly, yet irrevocably, redirected. It is a testament to the resilience of life, and a reminder that even under the sun's dimmed glow, survival is possible, but only for those willing and able to endure the trial of a world in shadow. The evidence preserved in ice cores and sedimentary layers further cements these mainstream theories, providing a temporal map of darkness repeated through deep time. Tiny bubbles of trapped air reveal fluctuations in atmospheric composition, spikes in sulfur concentrations, and abrupt drops in temperature, chemical and physical echoes of catastrophic eruptions and impacts. Each layer is a chronicle of hardship, marking years when sunlight was insufficient to sustain ecosystems in their usual rhythm. Forests show sudden die-offs, pollen counts decline dramatically, and marine sediments capture the collapse of plankton blooms that serve as the foundation of oceanic life. These records demonstrate that Earth has endured not one, but multiple episodes of prolonged darkness, reinforcing the idea that the phenomenon is neither anomalous nor singular. The cascading consequences of sunlight deprivation reveal the fragility and interconnectedness of life on the planet. Terrestrial ecosystems withered as plants slowed their growth or perished entirely, leaving herbivores starving and predators without prey. In the oceans, Plankton losses rippled upward through the food chain, causing fish and larger marine animals to decline in abundance or vanish altogether. The carbon cycle, intimately tied to photosynthesis, faltered, leading to further climate instability and ocean acidification. What emerges is a vision of a planet under siege, where the absence of light transforms the Earth into a theater of survival, a landscape of struggle and adaptation, yet one where the resilience of life repeatedly asserts itself. Recovery after these events, while inevitable, is never complete. Ecosystems rebound, species radiate into vacant ecological niches, and climates stabilize, but the scars of darkness remain. Fossil records reveal abrupt transitions in flora and fauna, shifts in evolutionary trajectories, and patterns of extinction and diversification that continue to shape life millions of years later. The paradox of Earth's resilience is profound. Life endures through extreme perturbations, yet the memory of those trials is preserved in stone, ice, and the genetic record of survivors. Each episode of darkness leaves a signature that can be read by modern science, a warning and a testament to the planet's capacity for both destruction and renewal. Mainstream theories, grounded in well-documented phenomena like asteroid impacts and provide a coherent framework for understanding how Earth could have experienced a decade or more of near-total darkness. They demonstrate that the mechanisms exist to dim the sun's gift, disrupt ecosystems, and challenge survival on a global scale. Yet they also illuminate a remarkable truth, that despite the severity of these events, life has always found a way to persist. The narrative is one of both terror and hope, a world periodically shrouded in shadow, yet repeatedly emerging, forever altered, yet enduring. Through the lens of these mainstream explanations, the mystery of prolonged darkness becomes both intelligible and awe-inspiring, revealing a planet resilient in the face of cosmic and terrestrial forces that would seem, at first glance, insurmountable. Beyond the confines of well-documented phenomena, scientists and theorists have explored more speculative and fringe possibilities, scenarios that challenge not only our understanding of history, but our perception of security in the cosmos. One such idea is that of interstellar dust clouds drifting through the solar system. Vast, diffuse, and almost imperceptible over human timescales, these clouds could nevertheless scatter and absorb sunlight sufficiently to reduce the energy reaching Earth. Though improbable, the physics is plausible. A dense enough field of microscopic particles lingering in the path of the sun's rays could create a prolonged twilight, disrupting climate, photosynthesis, and the rhythms of life in ways comparable to volcanic or impact winters. It is a reminder that even the emptiest reaches of space are not devoid of influence on our fragile world. Cosmic events of greater intensity provide yet darker possibilities. Gamma-ray bursts, the collapse of massive stars in distant galaxies, release streams of high-energy radiation that can strip away portions of a planet's atmosphere. Should one strike Earth within a few thousand light years, it could trigger chemical reactions that alter atmospheric composition and effectively dim the sky for years. While the probability of such a precise strike is low, history demonstrates that improbable does not mean impossible. The universe operates on scales indifferent to human experience, and the faint signatures of such events may be hidden within isotopic anomalies in the geological record, awaiting detection. Speculation also turns inward toward the sun itself. Periods of solar grand minima, like the Maunder minimum observed during the 17th century, hint that the star's output is not perfectly constant, Extended periods of diminished solar activity could reduce global temperatures and limit sunlight for decades, with consequences for ecosystems and the carbon cycle. When combined with other terrestrial or cosmic factors, even these modest variations take on profound significance, highlighting the tenuous reliance of life on the stability of its central star. Humanity, too, has demonstrated its capacity to replicate these ancient shadows. Models of nuclear winter, developed in the latter half of the 20th century, show that large-scale thermonuclear conflict could inject sufficient soot into the stratosphere to dim sunlight, cool the planet, and disrupt ecological and agricultural systems worldwide. These simulations provide chilling parallels to natural events, revealing that the same mechanisms that once cast Earth into darkness are now within our technological grasp, a mirror of deep-time cataclysms rendered by human hands. Even the most extreme fringe interpretations intersect with human culture. Ancient myths from cultures around the globe describe eras of endless night, suns swallowed by darkness, and skies dimmed beyond recognition. While these stories are often dismissed as metaphor, some theorists speculate they may encode distant memories of cosmic or terrestrial events, a cultural echo of the planet's recurring vulnerability to darkness. The line between myth and physical reality becomes hauntingly thin when considered against the backdrop of astrophysical and geological possibilities. In all these scenarios, the philosophical weight is unavoidable. Earth's survival depends entirely on a single, fragile star, a luminous anchor whose constancy feels eternal only because human lifespans are brief. Speculative or fringe though these theories may be, they converge on a singular, unsettling truth: the sun's light, the source of warmth and life, is not guaranteed. The world, resilient though it has proven to be, is always at the mercy of forces both human and cosmic, and the shadow of extended darkness, whether born of rock, fire, dust, radiation, or hubris, remains a haunting possibility, written into the architecture of the universe itself, viewed across the vast canvas of time and space. These speculative scenarios transform the Earth from a seemingly secure sanctuary into a fragile vessel, navigating a universe indifferent to life. Cosmic dust clouds drifting through the solar system, while diffuse and almost imperceptible over human timescales, could subtly reduce sunlight for years or decades, tipping climates into unfamiliar regimes. In this imagined shadow, ecosystems struggle, oceans cool, and the rhythm of life is disrupted, not with the sudden violence of an impact or eruption, but with the slow, relentless pressure of obscured light. The threat is subtle, yet cumulative, revealing that even emptiness itself can impose a quiet apocalypse. Gamma-ray bursts extend this narrative into the realm of deep-time terror. These stellar cataclysms, often occurring thousands of light-years away, could, in rare circumstances, irradiate Earth and alter atmospheric chemistry, stripping away protective layers and triggering prolonged dimming of the skies. While such events are extraordinarily rare, their consequences are severe, reminding us that survival on Earth is contingent upon a precarious balance between planetary resilience and the indifference of the cosmos. The faintest signals in isotopic records may yet reveal traces of these distant assaults, waiting to be interpreted. Evidence that the Earth has weathered forces far beyond volcanic or impact-driven darkness. Speculation also turns inward toward the sun, whose steady light feels eternal but is subject to variation. Grand minima, extended periods of reduced solar activity, like the Maunder minimum, demonstrate that even the most familiar celestial body is not immutable. Small reductions in solar output, compounded over decades, can chill the climate, slow photosynthesis, and cascade through ecosystems, amplifying vulnerabilities already stressed by terrestrial or cosmic events. In combination with other factors, these subtle instabilities could extend darkness beyond imagination, reinforcing the fragile dependence of life on the star around which it revolves. The specter of human-made darkness looms alongside these cosmic possibilities. Nuclear winter simulations, once purely theoretical, reveal that humanity now possesses the capacity to emulate nature's most devastating events. Soot and particulates lofted into the upper atmosphere could dim sunlight for years, causing abrupt cooling, crop failures, an ecological collapse on a planetary scale. Here, the lessons of deep time converge with contemporary anxieties. The mechanisms that cast Earth into shadow millions of years ago can, under the right conditions, be recreated by human hands. Even the most extreme interpretations echo through culture and memory. Myths of endless night, swallowed suns, and skies without light appear across continents and epochs, suggesting that human imagination may encode distant observations of cosmic or terrestrial darkness. Whether metaphor or memory, these stories resonate with the scientific record, offering a bridge between myth and measurable possibility. In all cases, the philosophical weight is inescapable. Life on Earth is sustained by the fragile, luminous gift of the sun, and the shadow of prolonged darkness, whether born of fire, rock, dust, radiation, or human folly, remains an ever-present, haunting possibility. The planet's endurance is remarkable, yet it is a precarious triumph in a universe indifferent to light, a reminder that even the most constant star is not eternal. In the present day, science has turned its gaze toward understanding the shadows of the past with a precision and ambition unimaginable even a few decades ago. Supercomputers now model the intricate dynamics of asteroid impacts and super eruptions, simulating the dispersal of dust, soot, and aerosols through the atmosphere with astonishing granularity. These models recreate the global dimming of sunlight, the chilling of oceans, and the cascading failures of ecosystems, offering a vivid reconstruction of events that once plunged the planet into extended darkness. Through these simulations, the mechanisms behind past mass extinctions are rendered tangible, allowing researchers to explore not only the scale of devastation, but the delicate threads of survival that life has repeatedly relied upon. Astronomers, meanwhile, have extended humanity's vigilance beyond the Earth itself. NASA, ESA, and other international observatories scan the skies for near-Earth objects, tracking asteroids and comets that could one day strike with catastrophic force. Each object catalogued, each orbital trajectory mapped, represents a step toward planetary preparedness, a conscious attempt to anticipate the cosmic hazards that have shaped the history of life. These efforts are complemented by geological expeditions, which venture into remote landscapes to uncover evidence of ancient darkness events hidden in sediments, ice cores, and fossilized soils. Each layer, each anomaly adds nuance to the narrative, revealing patterns that repeat across deep time and providing context for the simulations unfolding in laboratories and supercomputing centers. Advances in atmospheric modeling have further transformed understanding, linking changes in sunlight to the ecological crises recorded in the fossil record. By reconstructing how dust, ash, and aerosols circulated through the stratosphere during impact or eruption events, scientists can trace the effects on climate, photosynthesis, and the carbon cycle. Oceans, forests, and the delicate balance of the biosphere are no longer abstract concepts in these studies. They become measurable, responsive systems, sensitive to the deprivation of light and the stresses imposed by prolonged darkness. Parallel to these investigations, volcanologists maintain vigilant global monitoring of active volcanic systems, particularly those capable of supereruptions. Instruments measure seismic activity, gas emissions, and ground deformation, providing early warnings of the immense natural forces that could once again dim the skies. These scientific efforts are increasingly international and collaborative. Conferences and treaties discuss planetary defense strategies, ranging from asteroid deflection initiatives to contingency plans for catastrophic environmental events. The conversations extend beyond mere observation to practical preparation, acknowledging that darkness is not a relic of the past but a potential future challenge. By combining observational astronomy, geological fieldwork, climate modeling, and global monitoring, humanity constructs a multi-layered shield of knowledge, seeking to understand and, if possible, mitigate the forces capable of plunging the planet into extended night. Yet even amid these advances, there remains a humbling recognition. Earth's resilience is extraordinary, but it is not infinite. The planet endures, but the memory of darkness is written in stone, ice, and the genetic record of life itself. Current scientific efforts illuminate the mechanisms and probabilities, but they also underscore a profound truth that survival depends not only on observation and preparation, but on the intricate, fragile balance between light, life, and the forces that govern both. In this delicate interplay, the story of Earth's shadows becomes both a cautionary tale and a testament to the ingenuity and vigilance of those who seek to understand them. As these efforts advance, the interplay between technology and observation grows ever more sophisticated, revealing vulnerabilities and resilience in equal measure. Satellites track minute shifts in atmospheric composition, detecting sulfur dioxide emissions and particulate clouds that could presage global cooling. Seismographs, gas sensors, and thermal imaging monitor the restless hearts of supervolcanoes, while AI-driven models integrate this torrent of data to predict possible climate consequences with unprecedented precision. These digital simulations allow researchers to test scenarios that would be impossible to replicate. Physically, decades-long darkness, planetary cooling, crop failures, and ecosystem collapse. Each run of the model reinforces a sobering insight that even small perturbations in the balance of sunlight and atmosphere can ripple outward, reshaping the biosphere in profound ways. International cooperation has become indispensable. Observatories in multiple continents share near real-time data on potential impactors, while geological teams collaborate to identify the subtle signatures of past darkness events buried deep in Earth's crust. Conferences bring together astrophysicists, climatologists, volcanologists, and ecologists, each providing a lens on the same phenomena from different perspectives. This cross-disciplinary approach allows humanity to perceive darkness not merely as a theoretical threat, but as a tangible possibility with historical precedent. By connecting patterns across millions of years, from soot-laden sediments to asteroid trajectories, scientists can create probabilistic maps of risk, illuminating pathways for mitigation and preparedness that were inconceivable in previous generations. The philosophy underpinning these initiatives is as much about humility as it is about foresight. Despite advanced technology and unparalleled data, the Earth remains subject to forces beyond control. Cosmic objects drift silently through space, supervolcanoes stir beneath the surface, and the sun's energy, the ultimate lifeblood of the planet, is subject to subtle fluctuations. Scientific vigilance, no matter how sophisticated, cannot render the planet immune, but it can provide humanity with the foresight to respond, adapt, and survive. The knowledge gained through these efforts transforms fear into measured caution, turning speculation into preparation and abstract probabilities into actionable understanding. In this context, the modern pursuit of understanding prolonged darkness is both practical and profoundly philosophical. It bridges deep time and the present, linking the cataclysms of the past with the monitoring and modeling of the future. Each simulation, each observation, and each collaborative research project is a step toward safeguarding life against threats that once reshaped entire ecosystems. Yet they also serve as a meditation on the fragility of light itself. Humanity has learned to measure, predict, and perhaps even mitigate certain catastrophic events. But the enduring lesson remains that Earth's survival has always depended on an intricate dance between vulnerability and resilience, a dance conducted under the ever yet impermanent glow of the sun. In contemplating the episodes of darkness that have punctuated Earth's history, one begins to perceive a deeper truth. Light is not merely a physical phenomenon, it is the fragile thread upon which life itself hangs. Civilizations, ecosystems, and even the smallest organisms have relied upon the steady rhythm of sunlight to sustain growth, to mark the passage of time, to imbue the world with warmth and vitality. When that light falters, even briefly, the consequences ripple through every layer of existence. The record preserved in stone, ice, and fossilized remnants speaks of sudden collapses, of life forced into desperate adaptation, of ecosystems transformed in ways both subtle and profound. Darkness, both literal and metaphorical, has always been a measure of fragility, a reminder that survival is contingent, never guaranteed. Humanity itself is a child of catastrophe, emerging from epochs marked by shadow and deprivation. The species endured glacial winters, volcanic nights, and mass extinctions, its ancestors navigating landscapes where the sun's presence was uncertain and food scarce. This history of resilience has shaped not only biology but culture, myth, and imagination. Stories of endless nights, swallowed suns, and celestial shadows appear across time and geography, encoding collective memory of events that science is only beginning to reconstruct. These narratives serve as both warning and testament, reflecting an awareness that the balance of life depends upon forces far larger than any single species, yet intimately bound to its capacity to endure. Philosophically, the weight of these reflections is profound. Every living being depends upon a thin ribbon of sunlight, a seemingly permanent gift that, in truth, is fragile and contingent. The very survival of Earth is tethered to the steady glow of a single star, whose fluctuations, whether cosmic or human-induced, could transform life in ways unimaginable. Nuclear winter, a consequence of human hubris, offers a modern echo of these ancient events, a stark reminder that civilization possesses the power to replicate, on its own terms, the apocalyptic darkness that nature has imposed in the past. The irony is both humbling and terrifying. Humanity depends on light, yet now holds the capacity to extinguish it temporarily, on a planetary scale. In the quiet contemplation of these truths, one finds a sense of cosmic humility. Earth's story is written in alternating chapters of light and shadow, of survival and loss, of resilience carved from adversity. Each layer of soot in ancient sediments, each ice core bubble, each mythic tale of darkness is a meditation on the precariousness of life. The memory of darkness lingers not only in the record of the past, but in the imagination of the present, whispering a warning that may, one day, be realized again. Someday, perhaps, the earth will once more know the silence of a sunless sky. And when that day arrives, life will be tested as it has been before, reminding all who inhabit it that light is precious, survival is fleeting, and the cosmos is vast, indifferent and magnificent. And yet, amid the contemplation of fragility and cosmic indifference, there emerges a quiet awe, a recognition that life's persistence is itself miraculous. Humanity, with its capacity for reflection, memory, and foresight, bears witness to events that unfolded long before any conscious observer existed. The fossilized remains of plants and animals, the ash-laden layers in ice cores, the subtle shifts in isotopic ratios, all speak of a world repeatedly cast into shadow, yet repeatedly reborn. Each survival is an echo of resilience, a reminder that life is not a passive occupant of the planet, but an active participant in its ongoing narrative, adapting, evolving, and enduring even in the absence of light. In this context, darkness is not only a measure of threat but also a mirror reflecting the strength and tenacity inherent in the natural world. Humanity's place in this narrative carries both responsibility and humility. The sun, whose steady presence seems eternal to daily experience, is revealed by science to be a tenuous pillar of stability, vulnerable to variation and external influence. The knowledge that civilizations and species alike can be by the absence of light demands a philosophical reckoning. It invites reflection on the choices made in the present, the stewardship of the planet, the management of technological power, and the preparation for contingencies that span decades, centuries, and millennia. Nuclear winter is a stark embodiment of this tension, a reminder that the forces capable of creating planetary shadow are no longer solely external. Humanity itself now participates in the cosmic dance of light and darkness, with consequences that may extend far beyond the span of individual lifetimes. The memory of darkness, woven into geology, biology, and culture, challenges the human imagination to grasp the scale of vulnerability. It is a meditation on impermanence. Sunlight can falter, climates can shift, and life must navigate the consequences. Myths of sunless skies, once dismissed as metaphor, acquire new resonance when viewed alongside scientific evidence. They remind us that human perception is intimately connected to environmental reality, and that the stories passed through generations may preserve echoes of events that threaten survival on a planetary scale. In this convergence of science, history, and imagination, darkness becomes a teacher, urging vigilance, humility, and respect for the delicate equilibrium that sustains life. Ultimately, the reflection upon these prolonged periods of night is both sobering and awe-inspiring. Life's endurance against asteroid impacts, volcanic winters, and potential cosmic events demonstrates a profound resilience. Yet, it is a resilience forged in the crucible of vulnerability, reminding all who contemplate it that existence is contingent on forces both seen and unseen. The Earth's memory of darkness endures not merely as a scientific record, but as a philosophical testament. Light is precious, survival is provisional, and the story of our world is written in alternating chapters of illumination and shadow, each shaping the course of life in ways both subtle and profound. in the shadow of ancient events, where the sun once faltered and the earth was draped in unbroken twilight, one begins to comprehend the fragility not only of life, but of the civilizations that have arisen upon this planet. Darkness, in these profound instances, was more than an absence of light. It was a crucible, a test of endurance for every living organism, from the microscopic phytoplankton in the oceans to the towering forests that reached toward the sky. Fossil records reveal the devastating consequences of such periods, where plant die-offs disrupted entire food webs, where herbivores starved in the absence of new growth, and where predators faced the collapse of their prey. These are not merely scientific observations, they are testimonies to the extraordinary resilience of life, the capacity of species to adapt, migrate, or endure in conditions that would appear insurmountable. The Earth's biosphere, in this light, is not a passive stage for survival, but an intricate, responsive system, capable of absorbing catastrophe and reforming itself, though always bearing the scars of the trial. Civilizations, though recent, in the scale of deep time, are themselves a reflection of this endurance. Humanity has emerged from epochs defined by environmental upheaval, where ice ages, volcanic winters, and asteroid impacts shaped the evolutionary pathways that culminated in the rise of Homo sapiens. Our ancestors survived conditions of scarcity, climates oscillating between extremes, and landscapes transformed by natural cataclysms. Anthropological studies suggest that the bottlenecking effects of events such as the Toba supereruption nearly 74,000 years ago may have reduced the human population to a fraction of its former size, a stark reminder that our species' survival was never guaranteed. Yet, in these crucibles, adaptive ingenuity was forged. The development of tools, the mastery of fire, the formation of social networks, and collective knowledge, all emergent properties of a species, forced to endure environmental uncertainty. In reflecting on these events, one recognizes that the story of human survival is inseparable from the story of planetary darkness, that the same forces which challenged our ancestors continue to frame the philosophical questions of existence today. Philosophically, the periods of prolonged darkness evoke a contemplation of dependency, a meditation on the tenuous thread upon which all life hangs. The sun, a luminous constant in the human imagination, is revealed through geological and astrophysical evidence to be neither immutable nor infinite. Solar variability, cosmic events, and the random intersection of Earth with asteroid belts or interstellar dust clouds demonstrate that the light upon which life depends is contingent, subject to forces far beyond human perception. The very existence of the biosphere is intertwined with this radiant energy. The cessation or diminution of sunlight, whether gradual or abrupt, transforms the chemistry of the atmosphere, the dynamics of oceans, and the capacity of ecosystems. To maintain balance, carbon cycles falter, ocean currents shift, plant life struggles to photosynthesize, and the intricate web of interdependence that sustains life teeters toward collapse. In this awareness, darkness becomes a philosophical lens, a measure of fragility, a reminder that survival is never absolute, that life exists not in certainty but in the delicate negotiation with the conditions of the cosmos. Human hubris adds another layer of complexity to this reflection. The nuclear age revealed that humanity itself possesses the capacity to impose darkness upon the planet. Models of nuclear winter, developed during the Cold War, illustrate that the detonation of thermonuclear weapons on a large scale could inject soot and particulates into the stratosphere, dimming sunlight for years, cooling the planet, and triggering the collapse of agriculture and ecosystems on a global scale. The parallels between these human-induced scenarios and the ancient events recorded in ice cores and sediment layers are haunting. They reveal a continuity between natural catastrophe and technological intervention, demonstrating that while life has survived darkness imposed by cosmic and terrestrial forces, humanity now has the ability to create its own, a self-inflicted echo of the trials faced by every organism that has ever lived. In this convergence, the story of darkness becomes both a historical record and a cautionary tale, bridging deep time and contemporary responsibility, warning that the survival of future generations depends upon the awareness and restraint exercised today. Beyond the empirical and the human-engineered, darkness has persisted as a cultural and mythological motif, reflecting an intuitive understanding of its existential weight. Ancient myths and legends from across the globe recount periods when the sun failed, when skies darkened, and when the world seemed poised on the brink of annihilation. The Norse spoke of Fimbulwinter, an endless winter preceding Ragnarok. The Maya described eras when celestial fire was obscured, and in countless other traditions, the motif of sunless skies recurs, often linked with trials of survival and moral reflection. Modern scientific interpretation suggests that these narratives may encode distant memories of ecological and astronomical events, perhaps catastrophic eruptions, asteroid impacts, or regional climatic anomalies that left an imprint on human consciousness. In weaving together myth and science, one discerns a profound continuity, the recognition of darkness as both literal and symbolic, a force that tests endurance, teaches vigilance, and reminds humans of their intimate dependency on a delicate planetary system and a solitary star. The contemplation of these themes evokes a deeper philosophical humility, an awareness of humanity's place within the vast, indifferent cosmos. Life, for all its complexity and resilience, exists because of the balance of forces that allow light to reach Earth. The preservation of that balance has been neither absolute nor guaranteed, as the geological and fossil record attests. Prolonged darkness, whether caused by impact, eruption, or cosmic phenomena, underscores the precariousness of existence, reminding us that survival is contingent upon both adaptation and fortune. Even as humans have gained the capacity to measure, model, and potentially mitigate some of these threats, the fundamental truth remains unchanged. Life persists in the shadow of forces that operate on timescales and magnitudes far beyond individual or societal control. In this sense, scientific vigilance is both pragmatic and philosophical, a means of safeguarding survival while fostering a profound awareness of vulnerability. The Earth itself emerges as a text written in alternating chapters of light and shadow. Sedimentary layers record the sudden onset of darkness, fossil assemblages mark the collapse of ecosystems, and ice cores preserve chemical traces of atmospheric turmoil. Each record is a meditation on impermanence, illustrating that the stability perceived in the present is a temporary veneer over millennia of flux. Within these natural archives, one reads not only the consequences of environmental catastrophe, but also the tenacity of life, the persistence of species that endured, adapted, and radiated into ecological niches vacated by extinctions. These patterns reveal a paradoxical truth. Survival is possible even in the gravest circumstances, yet it is always provisional, contingent upon both the inherent resilience of life and the environmental circumstances it inhabits. The shadow of prolonged darkness, therefore, is both a warning and a testament, a lens through which the fragility and fortitude of life can be observed simultaneously in reflecting upon these events. The narrative expands to encompass the ethical and existential dimensions of existence. Humanity, as a species conscious of its vulnerability, bears a dual responsibility to understand the mechanisms of darkness and to act in ways that preserve light. Our scientific endeavors, from monitoring supervolcanoes to tracking near-Earth objects, from modeling climatic responses to preparing for potential nuclear or cosmic catastrophes, are attempts to mediate our dependence on the sun and the stability of the environment. Yet even with this knowledge, there remains an acknowledgement of limits. No technology can render Earth immune to the cosmic or terrestrial forces that have repeatedly cast it into shadow. Awareness, preparation, and humility are the tools available to bridge this gap, to navigate the delicate interplay between possibility and probability, between resilience and fragility. The reflection extends beyond human-centric concerns to a broader cosmic perspective. The sun, seemingly constant, is but one star among billions in the galaxy, subject to fluctuations, cycles, and the influence of interstellar phenomena. Dust clouds, gamma-ray bursts, and variations in solar output all serve as reminders that the planet exists in a dynamic, often hostile environment. Life's persistence, then, is remarkable not merely as a triumph of biology, but as a phenomenon contingent upon the alignment of countless variables, from the chemical composition of the atmosphere to the orbital stability of the planet and the constancy of solar radiation. Each period of prolonged darkness in Earth's history underscores this tenuous balance, revealing the thin line separating survival from catastrophe, light from shadow. Amid these reflections, one recognizes a continuity between the past and the present, between geological time and human consciousness. Fossils, sediments, myths, and simulations converge to form a coherent understanding. The episodes of darkness were neither arbitrary nor eternal, yet they carried profound consequences for every aspect of life. Humanity's awareness of this history adds a layer of responsibility. Knowledge is both a privilege and a duty, offering the possibility of foresight, preparation, and mitigation. The memory of darkness, preserved across scales from ice cores to collective imagination, demands a contemplative stance, an appreciation of the precariousness of existence, and a recognition that even the most resilient systems are subject to forces far beyond immediate perception. Ultimately, the reflection upon Earth's periods of darkness is an exploration of the interplay between fragility and resilience, between the ephemeral and the enduring. Life persists in spite of, and often because of, the trials imposed by cosmic and terrestrial forces. Civilization, emerging from these crucibles, carries forward the lessons encoded in genetic, cultural, and geological records. Scientific knowledge transforms fear into preparedness, speculation into strategy, and observation into wisdom. Yet, underlying all understanding is the haunting awareness that the sun's light, so central to existence, is neither guaranteed nor inviolable. The story of Earth is written in alternating chapters of illumination and shadow, in survival and loss, in resilience forged by adversity. Each epoch of darkness, whether caused by an asteroid, volcano, cosmic radiation, or human intervention, is a reminder of vulnerability, a meditation on dependence, and a testament to the enduring capacity of life to endure and adapt. The memory of darkness preserved in stone, ice, and myth, is a silent witness to the trials faced by life across eons. It lingers in the chemical signatures of ancient atmospheres, in the sudden disappearance of species, and in the tales of civilizations long vanished. It speaks to the philosophical truth that existence is provisional, that survival is contingent, and that light is the most precious and fragile resource upon which life depends. As humanity contemplates these lessons, it becomes both observer and participant, tasked with stewarding the continuity of life in a universe indifferent to its aspirations. The shadow of the sunless sky remains a constant reminder that the Earth's endurance is a product of resilience, adaptability, and chance, and that even as the planet emerges repeatedly from darkness, the spectre of future shadow is never far removed from possibility, and in the stillness of reflection, one confronts the profound intimacy between light and life. The sun, the source of warmth and energy, is revealed as both sustainer and arbitrator, determining the contours of survival and the boundaries of possibility. Life's persistence through epochs of darkness is a testament to adaptation, evolution, and the unyielding drive of biological systems to endure. Humanity's consciousness, capable of understanding and anticipating these forces, adds an additional layer of complexity. Knowledge becomes a bridge between fragility and foresight, between vulnerability and stewardship. Yet for all this understanding, the universe retains its indifference, and the possibility remains that one day, perhaps far in the future, Earth may once again experience the profound silence of a sky without the sun. In that eventuality, survival will again be tested, not only by the absence of light, but by the profound necessity of adaptation, ingenuity, and endurance. A reminder that life has always been contingent upon the interplay of environmental forces and intrinsic resilience. The Earth's record of prolonged darkness is thus a meditation on contingency itself, illustrating that survival is rarely the product of stability, but of flexibility, of capacity to endure extremes, and of the deep, often hidden interconnections that sustain ecosystems through periods of profound stress. In every fossilized leaf, in every layer of ash, in every isotopic anomaly preserved within ice, one reads the subtle narrative of survival against overwhelming odds, a narrative that is both humbling and inspiring in equal measure. These remnants speak not only to the past but to the future, hinting at the mechanisms through which life might navigate future episodes of cosmic, terrestrial, or human-induced darkness. As one contemplates the biological dimension, the remarkable persistence of life emerges as a central theme. Microbial life, capable of enduring extreme cold, radiation, and nutrient scarcity, becomes a model for understanding the foundational resilience of the biosphere. Extremophiles, thriving in conditions once thought incompatible with life, suggest that even in centuries-long periods of reduced sunlight, the mechanisms of survival may persist at the margins of existence. Plant life, sensitive to photoperiod and photosynthetic input, demonstrates both vulnerability and adaptability. Certain species evolved dormancy strategies, while others relied upon stored energy or subterranean structures to bridge periods of darkness. Animal populations, from herbivores to apex predators, experienced cascading effects, yet the record shows repeated rebounds, highlighting the dynamism of ecosystems in the wake of disruption. Through these biological lenses, darkness is not merely a passive absence, but a transformative agent, reshaping niches, influencing evolutionary trajectories, and challenging the continuity of life in ways that leave permanent marks upon the planet. The geological dimension complements this narrative, offering a structural record of catastrophe and recovery. Layers of volcanic ash, the chemical signatures of soot and sulfates in ice cores, and sedimentary anomalies across continents, serve as silent witnesses to the profound environmental upheavals that can plunge the planet into extended periods of dimmed or blocked sunlight. Supervolcanoes, such as Toba and Yellowstone, reveal the potential for eruptions capable of injecting prodigious amounts of particulate matter into the stratosphere, cooling the planet by degrees sufficient to disrupt global ecosystems. The global distribution of these deposits, sometimes spanning thousands of kilometers, provides compelling evidence that such events were not local curiosities but planetary-scale phenomena, capable of altering climate, light availability, and the trajectory of life itself. When coupled with the geological evidence of impact events, such as the Chicxulub crater, one begins to perceive the confluence of forces that have historically conspired to cloak Earth in shadow, and the enduring imprint these forces leave on the physical fabric of the planet. Astronomical factors further broaden the scope of reflection, demonstrating that Earth's vulnerability extends beyond terrestrial processes. Interstellar dust clouds, solar variability, and the potential for nearby supernova or gamma-ray bursts illustrate that the stability of light on Earth is a contingent phenomenon, dependent upon cosmic dynamics that unfold on timescales vastly exceeding human comprehension. While the probability of such events intersecting with Earth is low, their potential impact, global atmospheric chemical changes, prolonged, dimming, or radiation-driven ecological disruption underscores the tenuousness of the environment in which life evolved. Solar grand minima, periods in which the sun's output diminishes significantly over decades or centuries, provide historical analogues, offering insight into how even minor fluctuations in stellar output can cascade into profound ecological effects. In contemplating these astronomical variables, the Earth emerges not as a fortress against darkness, but as a fragile outpost in an indifferent universe, its fate intertwined with both the forces of the cosmos and the geological and biological systems that respond to those forces. The human dimension adds a profound philosophical and ethical layer. Nuclear winter, climate engineering, and anthropogenic contributions to atmospheric opacity reveal that humanity has become a participant in the dynamics of planetary darkness. The specter of human-induced light deprivation mirrors natural phenomena, offering a contemporary analogy to past events. Through modeling and simulation, researchers have demonstrated that large-scale nuclear conflict could trigger global dimming sufficient to collapse agriculture and destabilize ecosystems, echoing the mechanisms observed in historical supervolcanoes and impact-driven winters. This realization positions humanity as both witness and agent, capable of understanding and perhaps mitigating natural risks, yet also capable of precipitating darkness through technological hubris. Ethical responsibility, therefore, is inseparable from scientific understanding. Knowledge of these forces carries the implicit duty to safeguard life, to respect the delicate balance that sustains it, and to anticipate the consequences of our own interventions in the planetary system. The narrative of darkness also resonates through culture, myth, and collective imagination. Across civilizations, stories of sunless skies, prolonged winters, and cosmic upheaval appear repeatedly, suggesting a deep, intuitive understanding of the fragility of light. The Norse Fimbulwinter, the Mayan tales of celestial obscuration, and similar myths worldwide encode not only moral or cosmological frameworks, but potentially fragments of experiential memory, accounts of real phenomena interpreted through the lens of human perception and symbolism. These myths, when juxtaposed with scientific evidence, form a bridge between empirical understanding and human consciousness, reinforcing the idea that the experience of darkness, whether literal or symbolic, has shaped not only survival strategies, but cultural and philosophical frameworks. Light, or the absence thereof, becomes a measure of existential security, a backdrop against which humanity has constructed meaning, ritual, and narrative. Philosophically, the contemplation of darkness is an exercise in humility. It reveals that existence, for all its apparent permanence, is contingent upon variables far beyond immediate control. Sunlight, a source of energy taken for granted, is revealed as a finite and fluctuating resource. Life's persistence through multiple episodes of darkness illustrates not only resilience but also dependence, and the human capacity to reflect upon these forces underscores the remarkable, if precarious, position of conscious beings in the biosphere. The intertwining of past events, current observation, and future projections forms a temporal continuum in which humanity can perceive both vulnerability and potential, risk and foresight, mortality and adaptation. Awareness of this continuum fosters both philosophical reflection and practical vigilance. An understanding that survival is a combination of biological resilience, technological foresight, and ethical responsibility. The cumulative weight of these reflections shapes a contemplative vision of Earth's history and humanity's role within it. The record of darkness is a narrative of endurance, yet it is also a cautionary tale, emphasizing that light, the most elemental requirement for life, is neither guaranteed nor inviolable. Scientific observation, from ice core to supercomputer simulations, has elucidated mechanisms by which darkness has occurred and might recur, providing the tools for preparation, mitigation, and adaptation. Yet, even with such understanding, the awareness of fragility persists. Each eruption, each impact, each cosmic fluctuation reminds us that the survival of life is never certain, that stability is provisional, and that the biosphere exists within a dynamic system capable of profound and rapid change. Humanity's ability to anticipate, model, and respond is remarkable. Yet it is also a measure of our vulnerability, a reminder that knowledge, while powerful, cannot substitute for the delicate balance maintained across scales from microbial ecosystems to planetary climate systems. Within this framework, darkness takes on a dual meaning. It is both literal and symbolic, historical and future-oriented. Episodes of sunless skies illustrate the fragility of the natural order, while the capacity to reflect upon them and plan for contingencies demonstrates the unique position of conscious observers within the biosphere. The memory of darkness is preserved not only in sedimentary records, fossils, and isotopic signatures, but also in the cultural and philosophical consciousness of humanity. It serves as an enduring reminder that existence is contingent, that survival depends upon adaptation and foresight, and that the interplay of light and shadow is not merely an environmental phenomenon, but a defining dimension of life itself. To witness the world through the lens of these prolonged darkness events is to engage with a profound meditation on the nature of resilience, the limits of human understanding, and the responsibility that knowledge entails. The sun, whose radiance we experience as constant, is revealed as a fragile pivot around which the entirety of life revolves. Ecosystems, species, and human civilization itself are all vulnerable to its fluctuation, yet they are also capable of remarkable adaptation, creative problem-solving, and enduring persistence. Through reflection on these events, one begins to appreciate the intricate choreography of survival, the interdependence of life and planetary systems, and the extraordinary conditions that have allowed conscious observers to contemplate their own existence in a universe often indifferent to their presence. In the final reckoning, the shadow of past darkness is both a warning and a testament, a narrative that interweaves empirical science, historical insight, mythological memory, and philosophical meditation. Life has endured the absence of light. Civilizations have persisted through environmental upheaval, and humanity now stands as both steward and potential agent of darkness. This duality imbues the study of prolonged darkness with profound significance, revealing the fragility and resilience of existence, the ethical implications of knowledge, and the eternal interplay between illumination and shadow. The earth, ancient and dynamic, bears witness to these cycles, preserving in its strata, its ice, and its living systems the echoes of light withdrawn and regained, survival threatened and affirmed. Thus, as the contemplation draws to its close, the human observer is left with a meditation on continuity, vulnerability, and hope. The memory of darkness lingers not only in the physical record, but in the philosophical imagination, reminding all who reflect upon it that life is precious precisely because it is contingent, that survival is remarkable because it is provisional, and that light, the constant companion of existence, is neither infinite nor guaranteed. Someday, perhaps, the earth will again experience the profound silence of a sunless sky. And when that moment arrives, the resilience of life, the ingenuity of humans, and the enduring power of adaptation will once again be tested. In this awareness, there is both humility and awe, a recognition of fragility and a celebration of endurance, a contemplation of shadow and a reaffirmation of the luminous thread that sustains all life.